Hello, Geometry. Hopefully you've had a nice long weekend and happy Martin Luther King Day. So here we go. I'm finally finishing up this last section in Chapter 7 because I need to get these notes to you probably in a couple days because we have to do our quarter exam. In any case, solving right triangles. Now, when you get to high school, solving right triangles means you need to find out all three angles and all three sides. We've talked about finding the three sides. Now we need to talk about the angles. So in order to find an angle, you need the inverse tangent. So this is one of our learning targets. The inverse angle for tangent, sine, and cosine. And you can solve them in real life problems. All right, here we go. I do have my handy calculator. And let's see, it's clear. Why isn't anything clearing? All right, in any case. And you need to make sure, press mode, that you are in, do you see that? Degree mode, okay? The calculator has a default to be in radians. Just like moving from inches to centimeters, there's two different ways you can measure an angle. So we are primarily working with degrees, okay? So second quit. So make sure you press mode, which is this key right there, and go from there. All right. So warm up, here we go. If PR equals 12, okay, I'm going to be using this triangle for all of these, so I'll draw a separate triangle for each one. Okay, P, R, Q. If PR equals 12, this is my right angle, that's the hypotenuse, and angle R is equal to 19, find P. Well, this is little p, okay? Capital letters, you're using the angle value, so we're trying to find little p here. So according to this angle, this is adjacent, and this is hypotenuse. So remember, ka, toa. Okay, so adjacent hypotenuse, that's AH, we're going to be using cosine. So cosine of 14 is equal to, sorry, that's a 19, cosine of 19 is equal to adjacent over hypotenuse. So let's cross multiply. P is equal to, at the 12 times cosine of 14, so 12 times cosine of 14. About 11.64. I'm looking at my notes and I have an error in my notes. I'm not sure what's going on. Oh, did I press 14 again? I did. It's supposed to be 19. Second entry, let's change that to a 19. Why is the 14 in my head? Oh, that's really weird. Those three numbers kind of moved around a little bit. 11.346. 346. Okay. I just want to make sure that I have this. P, R, Q. This is little p. And the angle of R is 19. So adjacent over hypotenuse. Okay, so I just have a big mistake right here. Alrighty. Now let's draw another one. This is 58. Little r, which is right here, is 5. Find little p. Okay, so according to this angle, this is opposite, and I have adjacent. So which one uses OA? Tangent. So tangent of 58 is equal to opposite over adjacent. Cross multiply. P is equal to 5 times tangent of 58. 5 tangent 58. Oh, it's just about 8. How about this one? All right, P is at the top, so this is 60 degrees. Little p is 9. We want to find Q. Little q. All right, so according to this angle, I have opposite, and I need hypotenuse. Which one uses OH? Sine. So you should have known I would give you one of each. Sine of 60 is equal to opposite over hypotenuse. cross multiply, 9 is equal to q times sine of 60, and I need q by itself. So divide both sides by sine of 60. So I need 9 divided by sine of 60. 9 divided by sine of 60. About 10.39. So far, so good? All right, how about this one? We'll have to draw small. Okay, so little r is right here is 8. And I think this is supposed to be an equal sign. Whoopsie. P equals 12. Find q. All right, so this is just your Pythagorean theorem. 8 squared plus 12 squared is equal to q squared. So I have 64 plus 144 equals q squared. So this will be 208. And I don't think that comes out really nice. So, yep. So second square root, second answer, you get about 14.4222. I'm just going to leave it as q is equal to the square root of 208. So that's about 14. All right, sorry about the lack of space. And I rearranged it a little bit on your page. Okay, so you get the new pages. These are old pages, so my errors hopefully are only in here. All right, here we go. To solve a right triangle means to find the lengths of all three sides and the angle measure of all three angles. Okay, this is possible if you have two side lengths or one side length and an acute angle. Okay, and of course we're dealing with right triangles. So in a right triangle, so inverse trigonometric ratios. Let A be an acute angle. So this is angle A right here. Inverse tangent. Tangent A is equal to x, then tangent inverse of x is equals measure of angle A. All right, so basically what that means, tangent inverse, okay, of A. This is little a, this is little b, this is little c. So remember, tangent is opposite over adjacent. So A over B, and that's going to equal measure of angle A, okay? Sine inverse, okay, so sine of A is opposite over hypotenuse. And then cosine inverse, I feel like I'm going to sneeze here, adjacent over hypotenuse. All right, so now if you press the inverse of the functions, then the ratio of the sides, you're going to get the angle. So first, again, you need to make sure that you are in degree mode. Okay, second, quit. And do you see where the inverses are? Here's sine, right above it says sine inverse. So you will always press second sine. And then you can put the ratio of sides, okay? So that's how you find it. So if I just did 1/2, 1 divided by 2, 30 degrees. We know that, don't we? So here we go. Use a calculator to approximate the measure of angle A. So according to A, this is what we're looking for, which is like angle Y, I guess. We have opposite and adjacent. Again, it's going to be tangent. We don't know the angle, though. So I know tangent of A is equal to 31 over 23. But I need to know what A is. What's the angle? So if you wanted to do some craziness, you do this. 31 over 23. It's about 1.347. So how can I find tangent of that? Just do like guess. Tangent of 80 degrees. Too high. Tangent of 40 degrees. Too low. Okay, this can take forever. So do this instead. Tangent inverse of 31 over 23 is equal to the measure of angle A. So instead of just guessing and checking, which would be out of control, I'm going to do tangent inverse. So second tangent, and then 31 divided by 23. It's going to be about 53.4269 degrees. So let's just do 53.427. Now, remember I told you up here, if you're going to solve a right triangle, you need to know all three sides and all the angles. Well, if this angle is 53.427 and this is 90, how do I find that angle? Well, angle B is equal to 90 minus this 53.427. So it's 36.573. All right. Next page. Ooh, and this is pretty much it. We're going to have just the homework after this. Okay, so be a nice short video. Alrighty. Let A and angle B be acute angles. I can see the picture underneath this. Let me move that page. In two right triangles. Use a calculator to approximate the measures of angle A and B. Okay, well, let's see here. If I want the angle A, now remember, this is 0.24. That's a ratio of sides. That's the same as 24 over 100, right? So if I want angle A, sine inverse, you can put 24 over 100, which is silly. Or just do of 0.24 is equal to angle A. So here we go. Sine inverse of 0.24. Ooh, it's pretty crazy. Let's maybe if I turn this light that way, does that help a little bit? Okay. 13.8865 is your angle. So angle A is about 13.89 degrees. Okay, how about B? That's weird. Alright, so sine inverse of B of 0.37 is equal to, sine inverse of 0.37 is equal to angle B. Silliness. So second sine, that was 0.37. That angle is about 21.72. Solve the right triangle. Find all three angles and all three sides. Okay, so here we go. I don't know if you could see that in here. This is the depth. Okay, this is a right angle. All right, so let's first find D. So according to that angle, this is opposite. We'll call this X. Let's use sine. Sine of, can't read that, that's in blue, 39 degrees. Is equal to opposite of hypotenuse, D over 30. Cross multiply, D is equal to 30 times sine of 39, which is about, let's see here, 30 times sine of 39. 18.88 meters. Okay, so now let's find out what x is. So let's use cosine, because this is adjacent. Cosine of 39 is equal to x over 30, adjacent over hypotenuse. X is equal to 30 times cosine of 39. Probably shouldn't put a dot. Maybe I should put that. I don't want you to think it's a decimal. 30 times cosine of 39. 23.31. All right, so far so good. Last but not least, we have to find, because it says find all three angles, all three sides. Well, if I know this angle, how do I find this angle? Take 90 minus 39, which is 51 degrees. Okay, uneventful. And let's see here. Now, you could do a check if you want to do Pythagorean theorem with all three of those sides to see if it works out, but it should. A road rises 10 feet in horizontal, a distance of 200. What is the angle of inclination? Okay, so it's going to go up 10 for every 200. So according to this angle, I have opposite and adjacent. Well, that's tangent. So tangent of angle A is equal to 10 over 200. Well, I want to find the angle. So tangent inverse of 10 over 200 is equal to angle A. So second tan of 10 divided by 200. So it's about 2.86 degrees. That's okay. Well, actually, they labeled this alpha. Alpha. Okay. According to that picture. Alrighty. The last page I have here was a page like this, but I took that out and put two other informal little information there. So here's our homework. There's our Common Core standard, and have a nice evening.